Hello doctors, today's topic is going to be about anti-tubercular drugs. The anti-tubercular drugs are effective against mycobacterium tuberculosis, which causes tuberculosis. The drugs are divided into first line and second line. The first line drugs have high anti-tubercular efficacy as well as low toxicity, and the second line of drugs have high toxicity or low anti-tubercular efficacy or both. The first line drugs are Isoniazid, Rifampin, Pyrazinamide, Ethambutol and streptomycin. The second line drugs are Ciprofloxacin, Oflaxacin, Azithromycin, Amikacin and few other drugs. Isoniazid. Isoniazid is a prodrug, which means it converts into active form after metabolization by the enzymes. The mechanism of action of isoniazid is inhibition of mycolic acids, which is an essential constituent of the mycobacterium cell wall. Mycolic acids are formed by the proteins KASA. After isoniazid is administered, it is converted into an active metabolite by the enzyme KATG, which is mycobacterial catalase peroxidase. The activated form of isoniazid inhibits SA, which thereby inhibits mycolic acids, and thus isoniazid shows its bactericidal action and kills the mycobacterium tuberculosis. Ethambutol is a tuberculostatic drug, and the mechanism of action of ethambutol is not fully understood, but it has been found that it inhibits arabinogalactan, which is another important constituent of the mycobacterium tuberculosis cell wall. Arabinogalactan is formed by the enzyme arabinosyl transferase, and ethambutol inhibits arabinogalactan by inhibiting this enzyme arabinosyl transferase. The mechanism of action of ethambutol is shown, and it shows its bacteriostatic action on it. Bacteria has to produce mRNA, which is essential for its survival, and rifampin inhibits it by inhibiting the enzyme DNA dependent RNA polymerase. This DNA dependent RNA polymerase synthesizes single stranded mRNA from double stranded DNA, and thus rifampin shows its bactericidal action by inhibiting the DNA dependent RNA polymerase enzyme. Mycobacterium needs fatty acid and energy to survive. Pyrazinamide inhibits these both and shows its bactericidal action. Pyrazinamide is a prodrug, and its active form is called as pyrazinamic acid, which is converted by the enzyme pyrazinamidase. This pyrazinamic acid inhibits the enzyme fatty acid synthase, which is essential for the production of fatty acids. On the other hand, it inhibits the energy production of the bacterial cell, and thus pyrazinamide shows its bactericidal action by inhibiting fatty acids and energy production, which is essential for the mycobacterium to survive. Consider this as a bacterial cell which has mycolic acids and arabinogalactan, which is essential for the cell wall component, and the bacterial cell has a DNA in it. Inhibition of mycolic acid is by Isoniazid. Inhibition of DNA dependent RNA polymerase is by Rifampin, and inhibition of arabinogalactin is by Ethambutol. That's all for today, guys. Thank you.